Hi friends, welcome back to my channel. Today we are doing an exercise based on our previous lesson, which was statics. Still on engineering science N4. My name is Tsepo. Please subscribe to my channel to make sure you keep on receiving videos like this. Click that notification button so that you will be notified every time I post a new video. The exercise that we are doing, it's an exercise that I've taken from a question paper that was written on 1 August 2019. We are given this beam of length 20 meters and a mass of 20 kg. And we are asked to calculate first for the reactions, draw the shear force diagram, and also draw the bending moment diagram. So first, let's start with the mass. We know that when we are given a mass of a beam, we will have to consider it as a UTL. First, we must convert it into weight, which will give us 19.6, and then we divide by 10, which will give us 9. This will give us 196. And then after dividing by 10, we will get 19.6 Newton per meter, which we will put here as a UTL of 19.6 Newton per meter. And then now, after doing this, we convert the UTL into point loads so that we are able to use it. We will convert here and here, which will be 19.6 times 7 for this portion, and then it will give us 137.2 newtons. And then for this portion, we will say 19.6 times 3, which will give us 58.8. And then we put it here. For this will be 58.8 newtons. And then for this side, it will be 137.2 newtons. Now we have to calculate for the reactions. We know that the sum of the anti-clockwise will be equals to the sum of the clockwise. And then we will have something like this: A times 7, it's equals to 137.2 times 3.5. Then we will have plus 58.8 times 8.5 plus 20 times 10, which will give us 168.571 Newton. And this is the value of our first reaction, which is A. And then for moments about A, we will get something like this: 8 times we get something like B times 7 plus 20 times 3 plus 58 times 8, 58.8 times 1.5, it's equals to 137.2. 137.2 times 3.5, which will give us the value of B as 47.429 newtons. And then now we have our reactions, at A and at B. This is at B and this is the reaction at A. The next step from here is to draw our shear force diagram. We know how to draw the shear force diagram. We will transfer these lines. It's very important that you draw your beam up to scale, and then we start at this point. We can tell from here the first force from the left hand side, it's going down at 20, and then we will, from this point we will move down by 20, negative 20 to this point, and then from here to here there is a UDL, and then we know that when we have a UDL we will represent it using a diagonal line. So we will go down by 58.8, but we have to show that that 58.8 is representing a UDL. Therefore we will mark our 58.8 here. It will be from this point we will go down by 58.8, which will be 78.8, and then this will be 78, negative 78.8. we are going down using a diagonal line to show that this is a UDL. And then from this point, since we know that this is the value of A, we will go up by 168.571, which will give us a value of 89.771 straight. And then from here we also know that from this portion to this portion it's a UDL, meaning that we must represent this using a diagonal line also. And then we will go down, since it is going down, we will go down by 137.2, which we will put it somewhere here. And then to represent that this is a UDL, we will go down by a curve. We will go down by a diagonal line, sorry. And then we will have a value of negative 47.429. And then the value of B, we know that this will be, from here we will go down, we will go up by the same 47.429, which will give us 0. And this is our shear force diagram. And now the last thing that we have to draw, it's our bending moment diagram. We will calculate our bending moment diagram for this point, which is A, for this point, which will be B, and for this, which will be C. We already know that this point and this point, the bending moment of those 2 points will be 0. So we can say the bending moment at A, it's equals to 0 newtons per meter, and the bending moment at C is equals to 0 newtons per meter as well. And then now we calculate for the bending moment at B. And then we will say from B, looking at the diagram, I will use the left hand side as the side that we are taking moments about. We will say 20, and since 20 is going down, it will be a negative 20. The distance between this force of 20 from our point B will be 3 meters. And then we also consider this. It will be it will be negative, since this is also going downward. And then we will say 58.8 times, what's the distance between this point and this point? We know it's a UDL, we have converted for this whole portion, and then we locate it in the middle, which will be 1.5. Then we say 1.5 and then that will give us negative 148.2 newtons per meter. Now we have the information that we need for us to draw the bending moment diagram, and then we will say, we'll draw this line and then project. Here the bending moment is 0, and here the bending moment will be 0 also. We said the bending moment at B will be negative 148.2 newtons per meter. I will say negative 148.2 newtons per meter. Remember from our previous lesson, we said we represent a UTL by a curve when we are drawing it on the bending moment diagram. So from this point to this point, because we know that from here to here we are having a UTL, we will draw a curve just to represent that this portion is covered by a UTL. Now we also know that from here to here we also have a UTL. So from this point to this point we will also cover it using a curve. Now the problem about these 2 points is that we do not know whether the line will go like this or it will go above the line. So now before we draw this line, we have to get, or we have to calculate the turning point of this line, the maximum point where this line will touch before turning back to this point from this point. So we have a beam like this. This is our beam. We have a beam like this. One thing we know about the maximum bending moment, which will be the turning point of this, is that it will occur where our shear force diagram cuts 0, which is this point. But we do not know the distance from this point to this point, so that we can be able to calculate for its moment, which will be the maximum bending moment. Now our next step is to calculate the distance from this point to this point, which will be somewhere here, and then we will name this distance from here to here distance x. We know this is 3. From here to here it will be 7 meters. This is 3 meters. Now since we want the force, the moment of this point, from this point we will add each and every force that will be on the left hand side. From this point we will add every force in this direction, starting with, we know that this is our beam. We know that we have 20 newtons, and our 20 newtons will be negative. It's a negative 20 newtons. And then we also have our 58, which is also negative 58.8. And then now we know that our force is somewhere here. This portion, we know that it is covered by a UTL. Sorry, we didn't include this, which is our reaction A. Our reaction A is positive 168.571. And then we come to this portion. We do not know the distance of this portion. But we can say that because we know that it is covered by a UTL, the force of this portion will be negative first of all, because it will be going down. And then we say, because it is covered by a UTL, the UTL is 19.6 times, we will have to times it by the distance so that we are able to get its magnitude. We will say the distance from here to here will be x divided by this portion, which is 3. And then we say x divided by 3. And then when we look at this equation, the only unknown that we do not have is x. And then if we can be able to calculate for the value of x, we can be able to get this location, and then from here we know this location is where our maximum bending moment will occur. And then from there we will calculate the magnitude of the bending moment of this point, and then from there we can be able to get our turning point of the bending moment diagram. And then from here we calculate the value of x, which will be x, it's equals to, will equal to 0, and then our x will be 7.58 meters. Remember, from this point we add each and every force that will each and every force on the left hand side of this point, which gave us this equation. And then from here we will solve for the value of x, since x is the only unknown that we have in this equation. So now we know the value of x, which is 7.58. From here we will want the maximum bending moment, the bending moment of this point. Let's name it point Z. We want the bending moment of this point. We said we will look for the side which is less complicated. From here we can tell that the side which is less complicated is the right hand side. And then we know from here to this point it's 7.82, which will be 2.442 on the other side, 2.42 meters. And then we know that when we calculate the moments at Z, we will get something like, first we will start with this, which is the direction at B. This is the direction at B, and we know the value of B is 47. We'll say 47 times, it's 47.429 times, what's the distance between Z and B? That will be 2.42. And then we will say minus, because we know that from here to here it's covered by a UTL. And then the way we get, and then we will say the UTL, it's 19.6 times the distance from here to here, which will be 2.42. And then this is our force. When the force is converted, will be in the middle. Now we have to times by the distance between point Z and where our UTL will be located, which will be times 2.42 divided by 2, and it will give us a force of 57.385 newtons per meter. And now we know where exactly our bending moment will turn. We will construct this, and then we put our 57, which will be here, 57.375, which will be the turning point. And then from this we will say our bending moment diagram will be like this. this will be our bending moment diagram. And remember, this is the format that you must present your answer in. Start your beam, your shear force diagram, and then your bending moment diagram. All the information, all the calculations must be on this side, or if you run out of space, you can turn the page and write them. But this must follow each other. So that's basically the end of our lesson today. Hope this lesson will be of help to you.